Rosanna, what we want to try and do today is do the opposite of what we've done the last couple of days. The last couple of days, I've given you the equation, and I've said either graph it with technology or by hand and tell me some information about the graph. Today, what I want to do is I want to give you the graph, but not as an equation, as a series of data points. And we're going to see if you give me a series of data points, can I work my way backwards and figure out the best equation that comes closest to describing those data points. We call this the best fit line. Oh, and then our next lesson is going to be the best fit curve, which we'll come back to later. So when we try and find lines of best fit, I wrote here, we can use really many different methods. Here are two of them. The first is an estimated best fit. And this is what you kind of do in grade 11 quite a bit. So just look up. I'll show you what I mean. An estimated line of best fit would be if you had a bunch of dots. Do I have a bunch of dots here? No, I don't. An estimated line of best fit is if you have a bunch of dots, you literally lay your ruler down and try and go through as many dots as you can with your ruler, and that's your slope and your y-intercept. It's okay. It's quick. What we want to do, though, is see if we can do something mathematically. And the mathematical method is called a least squares best fit. What it actually does is it's a method that looks at every single data point, asks how high or how low it is compared to every other single data point, and finds a line that minimizes the distance between any of your dots. Say, what? Well, here's what I'm saying. Oh, pen stopped working. Let's see if this pen works. So maybe it's my pen. The estimated best fit line is easy to do, and I'll show you how. It's really inaccurate. The least squares method, and you are going to need to know this word, because I'll ask you to do it on a test. Best fit method requires lots of calculations. I used to know how to do this by hand. I've forgotten. I could rederive it. All I remember, Colin, is that if you had, well, in our example here, 1, 2, 3, 4, 5, 6, 7, 8, 9 data points, that was about 45 minutes of math, of just calculations by hand. And when you were doing science labs in university, you had way more than 9 data points. We were very grateful when this became technologized. So, you got your graphing calculators out. I said the following data is looking at the age of a tree and its diameter. So we have the age in years, and I'm going to put that on my x-axis in a second. And we have the diameter, and the diameter shouldn't be in years. Can you cross out years? And that should be the diameter in, I'm going to say, probably centimeters. 8 years, 9 centimeters. Yeah, that seems about right. Okay, sorry about that. I was cutting and pasting as I was making this. So, after 4 years, what was the diameter of this tree in centimeters? After 4 years, what was the diameter of this tree in 1? Hey, after what we've done, in fact, we've surveyed a whole bunch of different trees. So this tree we knew was 12 years old, and it had a diameter of 6 centimeters. This tree was 18 years old. It had a diameter of 9 centimeters. I kind of notice a trend. It looks like as trees get older, the diameter gets bigger. But what I'd like to try and do is see if I can find an equation to quantify that and use that to make predictions. We're going to use technology. So I said we're going to input this data into the stat function. So get out your graphing calculator. Go menu. And we now are going to be going to a new menu. I don't think, have we used the stat function yet? So for me, it's menu number 2. What menu number is it for you guys? 2. Oh, also number 2? Okay. Now, you may have some data in here. Do you have some data in here? Okay. Look up. Look up. Look up. Look up. To clear any column, and you're going to want to know this, which is why all of you want to look up, even if you don't have data. To clear any column, you want to delete all. Now, to get to delete all, it's actually sideways. You have to hit F6, and then del A, F4 is delete all, and then you hit yes. So clear any columns of data. So ready? Look up again. Most of you right now have a screen that says graph, calc, test, intro, dist. If you hit F6, that brings up the second menu, which is Tool, Edit, Delete All, or Insert. Again, if you hit F6, that cycles between those two menus. And once you've deleted all, go back to this menu so you have the Graph, Calc, Test, Intro, Dist. And you know what? This is going to be way easier if I have a copy of this lesson in front of me. The first list 1, that's going to be the X values. The second list 2, that's going to be my Y values. So all I'm going to do is really quickly type in the X values. I'm going to type horizontally on the piece of paper, vertically here. So I'm just reading right from the age and years. The first one is 8. What's the next one next to it? Type in a 19, hit enter. What's the next one next to it? 11. Type in that first list in column 1. So you're going across on the paper, you're going down on the calculator. And I think you should end up with 9 data points. So that's how also you know if you haven't missed any. And once you have that first column typed in, look up. And if you can't figure out how to do that, this is your chance to ask. I'll happily come over there and help you. Figure it's working? Whew. Okay. In column 2, in list 2, I want to type in the second information. How do you think I get to column 2? Yeah, arrow sideways, it takes me right to the top. And so next to the 8, what goes with the 8? The 9. And as long as I'm careful, I can type fairly quick. The 12, the 10, the 1, the 19, the 9, the 6, the 15, the 5. I noticed, Jake, they both end on the same line. That's my way of making sure I didn't accidentally miss one. If your columns don't match, you missed one, better go start over. Okay? Is there anybody who does not have these typed into their list? Y'all got it? So we can then display this as what's called a scatter plot graph. Got it, Jake? Yeah. Yep. Everybody else got it? So I wrote here, to do that, press graph and then graph 1. I'm not sure what it's going to be on yours, Justin. Press graph, which is what? F1, and then graph 1. And it says, you know what? When I graph the data, it looks like that. Does that form a nice, lovely straight line? No, because real-life data rarely is that nice. But can you see it kind of sort of forms a line. It kind of wants to form a line. So I'm going to quickly sketch this. So I'm going to move this over just a tiny bit. And let's see, there's going to be a dot right there. Dot right there. Is that working for yours, Justin, by the way? Yeah. Oh, good. There, there. Now, very quickly, you guys have the graph in front of you. Because I want this to look perfect, I'm going to cut and paste the graph because I'm going to cheat. So I'm going to go click right here. Clip. Ha-ha, look at that. Make this a little bit smaller. Delete. Okay? Where it looks like we have on the y-axis diameter and on the x-axis years. So I'm not going to be too fussy on how accurate your scatter plot is. Be roughly close. In other words, if a point is the highest, make sure it's the highest. If a point is the lowest, make sure it's the lowest, and roughly get them in order. Everybody got that? What I'd like to do is find the equation that best describes this. I mean, it looks roughly linear. You know what? This point right here, We would call that an outlier. You know what? I'll bet you that was a really long spring and summer and maybe a really warm winter. Right? That might explain why that tree has not very old, but seems to, or maybe the soil right there is unusually rich, but that's life. You can't get all nice data points. So I want to find the equation that best describes this. One way to do it is what's called using an estimated best fit line. And literally all that is laying a ruler down and saying, okay, right now I've got 4 points above and 1 point below. Here, this is pretty good. I've got 1, 2, 3, 4 points above, 1, 2, 3, 4, 5 points below. That's pretty good. Split the difference. That's a terrible way to do it. But it works. It's just really inaccurate. What we want to find is the mathematically most accurate line that will go through A, as many points as possible, and B, miss the other points by the smallest distance. You see where we're getting at, Silke? And there is a way to do this by hand, and it involves calculating all of the distances between your theoretical line and then squaring them and then square rooting. That's why it's called the least squares analysis method. And it takes forever. Oh, or the technology can do this for us. Oh, there should be little angels singing in the background. You should hear the little harp music because it is nice. Okay? So we're going to find the least squares best fit line. How? We're going to go calc, which is F1. I hope that's the same for you, Justin. Then we're going to press X for linear. X squared would be if you think it's a what? Parabola. X cubed would you think if it's a what? A cube. So unfortunately, software can't figure out what the line looks like. That's our human gift. We can glance at the data and say, I think it's a line. Once we do that, the software can then say, oh, you think it's a line? I'll try and find the line. Okay? So X. And then, did you guys have to hit AX plus B on yours? Okay, mine doesn't require me to do that. Mine is giving me an equation in slope-intercept form, except instead of mx plus b, what letter are they using for the slope instead of m? A. Okay? Now here's what it's saying. The line that best goes, does yours have a 0.6392? Yes? And does yours have a b value of 1.38? Oh, actually 1.39. Okay. It's saying the line that best fits this data is as follows. Y equals, what's your slope? What's A? Sorry? Is that rounded up? Let's go 0.64. X plus, what's the y-intercept? 1.39, let's say. Now that's from my graphing calculator, but I wrote here, make sure to change y and x to d for diameter and a for age. So as an actual equation, we would say this. The diameter, based on my data, if I was doing a field study and I was now trying to predict other trees' diameters, apparently is 0.64 times the age plus 1.39. That's the least squares best fit line. You okay with that? Go back to look at your screen here. The other interesting number is this here, the letter R. Any of you that are planning on going into nursing or into medicine or into science, this letter R is hugely important when you're doing research. Okay? R is called the correlation coefficient. It's a decimal. The closer that decimal is to 1, the more accurate your equation is, the more likely it is that your x variable does affect your y variable. So Jake, let's suppose you were doing research in a lab and you were graphing two pieces of data, I don't know what, and you got a correlation coefficient of like 0.03, probably the first thing has no effect on the second thing. You'd throw that research out and you'd say, I got to go look at something else. If you get a correlation coefficient of like 0.9, the odds are you'll be a millionaire. The drug company will purchase that from you for several $billion because you found something that cures things. Right now in medicine, we're lucky if we get correlation coefficients of like 0.3 or 0.4, especially in cancer medication and things. It's saying, well, this seems to have some effect, but there's probably several thousand other factors that also affect this. Life, okay? This one here, I cooked the numbers. I gave you a reasonably good correlation coefficient of 0.75. Well, no, you know what? As trees get older, what happens to their size? They get bigger. I think that's reasonable, and we've kind of proved that with this data here. Is it a one-to-one relationship? Does twice as old mean twice as big? I don't think so. Otherwise, I'd have a higher correlation coefficient. You know what? Maybe there's other factors that play a role. Soil type, winter length, spring, I don't know. Okay? Using the equation, turn the page. Using the equation, you know what? Can all of you write the equation at the top of the page? I'm going to scroll back. Can you copy D equals 0.64a plus 1.39 at the top of the page? And I'm going to go, hello, where is it? Whoa, I didn't want to do that. Let's try that again. Nope, not going to let me. Okay, never mind. Let's see if I can go like this. Copy. Paste. There we go. Using this equation, find out what the diameter of a 15-year-old tree and a 30-year-old tree would be. Okay. Let's draw a little line down the middle. In this equation, what does the letter D stand for? Diameter. What does the letter A stand for? Age. So it looks like here they're giving me an age. If I want to find the diameter of a 15-year-old tree, I think the diameter of a 15-year-old tree is going to be 0.64. Put 15 in for the age. In theory, what's the diameter of a 15-year-old tree? Can someone go 0.64 times 15 plus 1.39 on their calculator, please? Or you can do it in your head. What'd you get? 10.99? Is that right, folks? Yeah? Centimeters. Let's find out the age of the diameter of a 30-year-old tree. That would be D equals 0.64 times 30 plus 1.39. $20.59 centimeters. So we can use this equation to make predictions. And you can use that equation in two ways. Okay? The first way is you can do it by hand by copying the equation onto a piece of paper, plugging in the number, and literally typing it into your calculator. However, we can also be really, really clever. These calculators are set up really nice. You can also copy the equation to the table function. So if you go back to here, Justin, I'm not sure if yours has this option, but the rest of us, we have an option to F5 copy. So hit F5, copy the equation. And then I think if we go menu table, which for me is menu 7, and hit enter. Oh, no, hang on. I got to go back here. Give me a second. Let me go back to stat, graph, graph 1, calc, line, copy. I think all I do, okay, so you ready? Back to here, folks. Go back to your menu thingy. Go back into the stat menu. And you might have to go graph again, F1. Graph 1 again, F1. Calc again, F1. X variable again, F2. Everybody with me? With me, Brooke? And if you hit copy, I think if you just hit enter right now, it takes you to this screen, and just hit enter, it pastes the equation there. It's pasted the equation as 0.639. It's off the screen, but it's there. So I can either graph it, or because it's pasted it here, it's also pasted it in the table menu. If you go menu, go to table, I hope there's going to be an equation there. Is there now? Okay. I want to set the table. Now, what does number 4 say? Rachel, can you read number 4 to me, please? Check. Keep going. What 2 diameters do I want to find? Here is the laziest way to do this. Set as your start 15. Set as your end 30. And what should I go up by if I want to make sure the 15 and the 30 appear? Go up by 15. And hit F6 table. Oh, hang on. I turned mine off accidentally. Hit F6 table. There. This is a bit more accurate than our equation, because our equation, we rounded off the values to 2 decimal places. So it's saying, actually, it's not 10.99, it's 10.976109222, 20.5648. Did you zone out? Oh, the arrow sideways, right? So if in other words, I can use the table, and by being clever in my start and finish and what I'm going up by, I can find whatever values they want without bothering to type by hand. It's convenient. So using the table feature, I'm just going to go like this. Oh. Delete. Make this a little bit smaller. You folks can just copy down from your table. Oh, D when we're 15 is, we used a capital letter D, Mr. Dueck. D at 15 years is 10.976, and D at 30 years is 20.564. Ellen, a little more accurate than our rounded off equation. Yeah. So again, what we're going to be learning today, what we're going to be doing today, Christina, is if I give you some data, can we turn that into an equation? And can we use that equation to predict other values? Okay? Today they're going to be linear. Next day we'll also say, hey, what if they're curvy? Example 1. The 1 hour record in the furthest distance traveled by a bicycle, sorry, the 1 hour record is the furthest distance traveled by a bike in 1 hour. So this table below shows the world record distances and the dates that they were accomplished. This is accurate. I Googled this. So let's go to our stat menu. Let's enter this data. First thing we need to do is we need to delete this list. How? Okay, how? It's going to be arrow sideways, F6, delete all, yes, and then move to the next list, delete all, yes, and then arrow sideways once more, so we're back to our graph calc test menu. Oh, and arrow left so that you're in list 1 at the top. Right? I guess in the first column we have the years. 1996, 1998, 1999, 2002, 2003, 2004, 2007, 2008, 2009. And then carefully type the distances. This is how far someone was able to pedal in 1 hour. Type the distances next to them. So 1996 was 78.04, 79.14, 81.16, 82.60, 83.72, 84.22, 86.77, 87.12, 90.60. And when you're done typing in the data, look up. You guys are the tech generation who grew up with phones. I thought you were good at typing on number pads.
It's not the same as on a phone, Mr. Dueck.
Oh, fine.
On a phone, the 1, 2, and 3 are on the top. On a calculator, the 7, 8, 9 are on the top.
It's true. Why is that? I have a video. I'll show you another day. Colin, you done? No? Okay, keep going. The rest of you, if you want to try seeing if you can figure out how we... So part A says use technology to create a scatter plot and then find the equation of the line of best fit. Remember what we hit. If not, I'll do it with you. Are we almost there, Colin? Are you done? Okay, I said look up when you're done. I've been waiting here. Okay, everybody done? Okay, how do we get the scatter plot? How do we graph a scatter plot? Graph. Let's put it in graph 1. You can put it in different graphs and store them, but my default is I'll store it in graph 1. What do you notice? What's the trend? It looks like we're pedaling further in an hour. Okay? If it was going downhill, that would tell you that whatever we were observing was getting smaller as time progressed. Okay? So do a quick sketch of that scatter plot. I'm going to cleverly just copy it right here. And then also find the equation of the line of best fit. Which was do a calculation from this screen. Tell it that you're pretty sure that it's just an x, not an x squared, not an x cubed, not just an x. So calculation, it's just an x. And I seem to be getting that there. Y equals, let me make sure I'm getting what I got earlier. Yes. You getting that okay? Y equals 0.85848 x minus 1,635.73. Is that okay? I'm going to copy that screen here because I got kids away, and that way they know what the screen is supposed to look like. Okay. So What are we measuring? Look at my table here. What are we measuring on the y-axis? Distance. What would be a good letter to use for distance? D, uppercase or lowercase. What are we measuring on the x-axis? Year. What would be a good letter to use for year? It's going to be a little strange because we'll have the y where the x normally is, but it's a year, not an xy coordinate. So as an equation, it's going to look like this. D equals 0.858, I'll go right to there, 5 year minus 1,636. And then I said, interpolate a possible world record distance for the year 2006 by substituting into the equation. So I can do that two ways. I can do this manually by going 0.8585 times the year 2006 minus 1,636. Or I can cleverly use the technology. I can say, hey, copy this to there. I hope that worked. Hey, it did. I can go menu, table, set the table. How about from 2005 to 2007? If I want to make sure I include 2006, what should I go up by? I'll go up by ones. And if I hit table, oh, I do this every time I hit enter. Ah, this is my fault. I keep hitting enter twice on my. If I hit table, looks like in 2006 I should be hitting, in my rounded off equation, 86.15. In my not rounded off equation, 86.3, well, 86.378600526. Is that okay? I don't care which method you use. I'll be honest. If I'm finding more than one value, I'll go to the table because then I only got to type it in once and it'll give me all the values. If I'm only finding one value, I'll probably just do it by hand. Okay? So D equals 0.8585 times 2006 minus 1636. If I do this by hand, I got D equals 86.151 kilometers. Then part C, I said copy the equation into the table function, set up a range to find a possible world record distance for the year 2006. So I did that right here. Okay. Here I got D equals 86.38 kilometers. That's our guess as to what it should have been. The actual world record in 2006 was 85.99. We're pretty close. This is how we can start to make guesses as to, hey, 6 years from now, how fast will people be running? Although that one's not linear. This works for linear data. For curvy data, it becomes much more complicated. But yeah, you can use this to make predictions. Okay? You with me so far? So, oh, compare your estimate. Pretty close. We are within, what? 0.6 kilometers, pretty much. 85.9, that's basically 86 kilometers, 86.38 or 86.151. We're pretty close. Okay. Hey, how far do you think we'll be in 2015? We could make that prediction if we wanted to as well. And be curious to see how accurate we are. Any questions? I thought I was only going to get through half the lesson. It's the next lesson that's the big long one. This one's a bit of a shorter one. So your homework, you have several things to work on. Take-home quiz. But you can try then. Number 1, there's your data. Find the best fit line. Use the equations to find some information. Number 2. Number 3. I'm going to be assigning all of it, yep. Oh, hey, goalies. Sorry, that's a little sore spot for some of you, I realize. But it somehow seems appropriate to go back to the 1997-98 season when the Canucks had no goaltender. Oh, sorry. 5 is good as well. I think that's sure, 6. You know what? I think I might nuke one of these. Let me see. You know what? I'm going to nuke number 1 because that has the most data entry. Although it's kind of cool. I'll say do 2, 3, 4, 5, 6. I made up an answer key in a hurry. It's entirely possible with me typing in all this data that I might have typed in the wrong data piece, and that would give my answer slightly different from yours. So if you're getting an answer that's different from my equations, check with a neighbor. If both of you have exactly the same equation, probably then I'm the one that made the mistake. I was doing this in a big hurry 2 weekends ago, so. Okay.